All right, GM everyone. Good evening. Very excited to be here this evening to talk about one of the things that I really enjoy doing, that is setting up nodes. It's been an amazing journey trying to set things up all from scratch. And then we're going to talk about nodes and how to set it up. And no other node than Starknet node. So some of us here will want to ask, what is Starknet? So Starknet is a layer 2 scaling solution. There's a problem currently with Ethereum. Ethereum has a problem of scaling, and that is why layer 2 solution called Starknet, which leverages zero knowledge proving system, was bettered, right, by Starkware team. And then they've gone from a centralized approach to a decentralized approach. The first instance was StarkX, and the second instance of their approach to scaling Ethereum is Starknet, right, which is permissionless, and you can actually access it, right? Writing your smart contract using Cairo, you can actually deploy the solution without meeting the Starkware team for them to give you permission access, right? Now, on Starknet, there is what we call nodes. And on Ethereum too, there's what we call nodes. So some of us who are here may be wondering, what is a node? I think we'll start by describing what a node is. So if you don't know this today, that a node is just a computer running a software. So some of us will be wondering, what is this node that I'm talking about? But the thing is, one thing about node is the fact that every node is just a computer. What is a computer? Some of us will really want to understand what a computer is. A computer is nothing other than an electronic device that has storage, memory, and CPU, right? This is basically what a computer is, right? If you have a computer and that computer is running an Ethereum client, right? That computer is automatically a node. So I think some of us will be wondering, what is this Ethereum client, right? So that is the essence of this session this evening. I'll be covering all of that, walking you through what you need to understand, what will make you run a node. So now you have your computer. That computer, I'm going to simulate it as when some of us, probably you bought your mobile device, you have a phone. So like this, phone now, you have this kind of like phone, you have a phone. When you purchase this phone, something happens. It's kind of like blank. When you buy a phone, nothing is there. You have no apps. You have no Telegram, no Twitter, no WhatsApp. Basically, an empty computer, an empty mobile device. So what do? You go to an app store. In this case, if you're using a Google phone, you go to Google Play Store, and then you install WhatsApp, Telegram, and all of the apps you want to use in your mobile device. On the other hand, for iOS, you go to App Store, and the same thing, you download these applications. It's trying to like marry it together with what a node is, right? We have described a node as a computer running an Ethereum software. So we talked about what a computer is. A computer is just a device that has an electronic device that has memory, and it has storage, and has processing units, right? So think of the node as that empty phone, right? You go to the market, you buy an empty phone, and nothing is there. Now you have to install some software in it, right? In this case, WhatsApp. In the same vein, that empty computer that is just lying, that has memory, storage, and CPU, you just go and install what we call an Ethereum software called client, right? So once you install this client and it's running on your computer, automatically this software downloads the copy of the Ethereum blockchain and verifies the validity of every block. All the things that has happened, right? The history of the blockchain, it downloads it to your computer, right? That computer, that software that you've installed will enable you to talk to other computers in the network. So each of these computers are nodes, right? I'm going to talk about this, just kind of like a high-level overview of what a node is. So think about it in the same way you have a phone, you have installed your WhatsApp, and you're chatting with people. In a normal computer, you have installed an Ethereum client, right? It's a node. So now we have two categories of clients, right? What categories of Ethereum software will you download to automatically say that you're running a node? So we have two categories of this software, right? We have the consensus client and the execution client. So what are all of these execution and consensus, right? Before Ethereum transitioned from proof of work to proof of stake, it was nothing other than just ETH1, right? There was nothing like consensus layer. There was nothing like consensus client. Ethereum was using a proof of work consensus algorithm. And what that meant was we just had one Ethereum node, right? So if you're running a node, you're just running what we describe today as the execution client, right? We have software such as Netamind, Get, that's Go Ethereum. So all of these softwares are open source softwares, right? Written by different teams, and then they are written in different languages. Go Ethereum is the most popular execution client, right? This Go Ethereum is just an open source code written in Go, right? Anybody can actually pull it and run it on their computer automatically. Before Ethereum transition to proof of stake, you will be running a node. But as Ethereum transition from proof of work to proof of stake, that was what gave rise to, in 2022, 15th September, right? That was what gave rise to, what's it called? We can actually say, for you to run an Ethereum node, you must run the consensus layer and the execution layer on your machine, right? So we have different instances. Like I mentioned, for the consensus layer, we have, so what is a consensus layer, right? Or consensus client? You can actually call them, any one of them. You see them in so many documentations. They are used interchangeably, right? I don't know if anybody has any question. If you have any question, please feel free to ask your question. I will go over them. Before we start writing code, so we'll have a better understanding and start running these commands and start writing all of these to make sure everything works. Any questions so far? So let me recap, right? A node is a computer running what? An Ethereum client. This Ethereum client, before Ethereum transitioned to proof of stake, it was just one thing you would run. If you're running that Ethereum client, you're running a node, right? You're going to run what we call any of the either Go Ethereum, Netamind, which is Netamind's implementation of this Ethereum software. It is written in .NET, right? .NET is a framework of, so yeah, it's written in .NET. It's a framework of C#. And then we have Hyperledger Besu, which is an implementation of this software in Java. And for those of us who know Erigon is an implementation of Ethereum software in Go. So yeah, so if you're running any of these clients before Ethereum transition to proof of stake, you are running an Ethereum node. Since Ethereum transition from proof of work to proof of stake, everything changed, right? That means if you're going to run an Ethereum node, you're going to download and install on your computer two things. You're going to install the execution client, and you're going to also install what? A consensus client, right? So if you're going to install these two things, you are running a node. I don't know if that makes sense. So on one hand, you install an execution client, and on one hand, you install a consensus client. So what is an execution client? An execution client is a software implementing the specification for Ethereum execution layer as it tracks network upgrade and implements core methods like apply, fork, state transition. All of these things, all of these methods are kind of like specifications for Ethereum, right? For Ethereum execution client. So any client that is specified as an Ethereum client, right, must implement these specifications, right? So yeah, the execution client has what we call a JSON RPC API, which is a collection of methods that all execution clients must implement, right? So this is what allows the communication between the consensus layer and the execution layer, right? So basically this. Don't worry, all of this is kind of like theoretical. We're going to see how we run it. And on the other hand, talking about the consensus clients, right? A consensus client is just a software implementing the consensus core specs, right? The core specifications for Ethereum proof of stake, right? And this is divided into features, and these features are researched and developed in parallel. then consolidated into sequential upgrades when ready. So Ethereum has transitioned from a lot of phases, right? And each of these transition is codenamed after is kind of like giving a code name, right? We have phase 0, which was when Ethereum transitioned to proof of stake, and this is the different epochs where all of these upgrades happened, right? And again, in addition to all of these sequential upgrades that is tracking, right? It has some other specification is implementing. We have the Beacon API, we have the Engine API, we have the Beacon metrics, the builder specs. So any software written by any team implementing this is automatically what we call a consensus client. So let me recap again. You must run an execution client and you must run a consensus client for you to run an Ethereum node. Somebody will be asking, how does this relate to Starknet? If I'm going to run a Starknet node, remember, Starknet is an L2 that is referencing a base layer, a settlement layer, in this case, L1, in this case, Ethereum. So you must, first of all, if you want to run a Starknet node, you must set up an Ethereum node, right? So this Ethereum node consists of two components, right? You must run on the consensus layer, you must run so many implementations of any, so we have so many implementations of the consensus layer, right? The consensus client. We have Lighthouse, which is an implementation in Rust. We have Prism, which is a Go implementation. We have Grandin, which was recently launched, an implementation also in Rust. We have Nimbus, which is an implementation of MIM, a special programming framework for implementing the consensus specs. And I think we have Teku. So all of these things, and Lostar. Lostar is written in Teku is in Java, then Lostar is in TypeScript, right? I think I can actually see Lostar. So yeah, so Lostar can go here. So Lostar is an Ethereum implementation written in TypeScript. So basically, all of these things I'm mentioning are code bases, right? Open source. So I think I mentioned Lighthouse. So you can actually go there and see for yourself Lighthouse. So this is a GitHub repo. Basically, you can actually go there and see all of these things. So these are all open source implementations of Ethereum in different languages, right? Like I mentioned earlier. So you can actually go check out the issues after this call. This is where protocol engineering comes in. You want to kind of like know what is happening. You're running a node and you're facing any issue. You can actually come here, create an issue, and the maintenance of the code base reviews your issue, and they can fix it, fine. If you can actually fix it yourself, you're contributing to the future of the resilience of the network. So basically that. So yeah, so all of these things are open source. You can actually go there, pull them, and then run them on your machine. So I don't know if that makes sense, right? So yeah, so basically, like I mentioned, right, we have two things. We have the consensus client. So yeah, so this is a pictorial depiction of these two components working together, right? So some of us will be wondering, what is the business of these two clients? The consensus client is, okay, let's talk about the execution first. So execution is kind of like the front end, right? While the consensus is kind of like the back end, right? So I'm trying to like make it relate to some of us who really are coming from programming, like, right? So you want to build a web application, you have a front end, you have a back end. So I'm trying to like simulate, using that same analogy to simulate what I'm trying to describe here, right? So the execution client, like I mentioned, we have so many implementations, like I earlier mentioned. I think let's go to Ret. Yeah, so Ret is a Rust implementation of the execution client, very modular, very lightweight. We have so many of them. We have Erigon, Erigon. So yeah, so you can actually go there. They are open source. You can actually check them out on your own. Basically, it's written in Go. You can, if you're proficient in Go, open source, go there, contribute. So yeah, so let's go back to what we're showing. So yeah, so the execution client. So we remember this, something is happening when we send the transaction, probably from your MetaMask, right? Your transaction is propagated to the mempool, and from the mempool, it's aggregated by a validator, and a block is formed, right? So this is the life cycle. When you send a transaction, and what is responsible for handling that transaction is the execution client, right? The execution client is responsible for handling transactions. It helps to gossip transactions, and the EVM, it manages the EVM and state management, right? Post-transaction phase of a transaction lifecycle, that is where the consensus layer comes in, or the consensus client, right? It handles the consensus logic. We know when we say POW, proof of work, POS, proof of stake, the component responsible for handling that is the consensus client. We're going to talk about this when we start setting things up in our terminal. So please follow along and then feel free to ask questions. Kind of like trying to like lay the ground so that anybody interested in understanding the core concepts can actually do so in the course of this session today. So yeah, and then they both talk together using the engine API. I think before we come here, I think some of us will be wondering, what is the benefit of even running a node, right? So let's even talk about the benefits, right? I don't know if there are questions. I would like to take these questions. Otherwise, I will fire. You can actually use the chart. I'm also taking a look at the chart to see what's happening. If you have any questions, feel free to ask your question. All right, so in the absence of any question, I'll proceed. So what are the benefits of running a node? Now, the first thing for me, you cannot be censored, right? A country can say, you know what, we don't want anybody using a particular wallet. It can actually be blocked. Even if you're going to use the wallet, they may prevent access to the server of the RPC provider of that particular wallet. So what does that mean? You may have something like you have something installed as MetaMask. MetaMask under the hood is using their native provider, right? The RPC provider, infra. So some of us who are writing Solidity, when we want to kind of like integrate our front end to our contract, you must use an RPC provider. And that is where platforms like Infra and Alchemy comes in, right? You can be censored by this platform. They may say, you know what, we don't want any transaction originating from this particular IP or this account to be propagated to the network. And what that means is you cannot use the network, right? And basically, this thing also happens when you kind of like, I think every node provider, RPC provider, they restrict the number of calls you can actually make, right? When you go to Alchemy, Infura, there are a lot of specifications of what guides the number of requests you can actually make in a particular minute, right? You cannot, if they say you can only make 5 requests in a minute, you cannot exceed that. Any attempt to make the 6 transaction, you'll be rate limited, right? So this is one of the things that happen when you don't run your node, right? Somebody is providing a service and you're leveraging that service to propagate transaction to a decentralized network, which is not supposed to be. So that is why we should run our own nodes, right? With your own node, there's no guarantee that you can be stopped. You just from your CLI or with any of your tools can actually build a lot of things to easily send transactions to the network and nobody will censor your transaction, right? The guarantees of blockchain is that it is censorship resistant, right? No, that means nobody can prevent you access from reading and writing to the network, right? So with centralized third-party providers like RPC, MetaMask, unfortunately, most of these providers, right, they can censor you, right? I think there were instances where I think some providers censored some, I think, was it Russia? I'm not so sure, but I think they censored some people, right? I think was it either China or Russia or both, but I'm not so sure. But I think there were instances where certain people from certain regions, I think some of these providers were mandated. I think MetaMask inclusive, because MetaMask is using Infura, which is their provider, their RPC provider by default. So you can actually be censored. So basically that. So with your own node, nobody can censor you, right? Then the second one is privacy and security. Please note this. Privacy does not mean that your transaction will not be seen. What privacy is saying here is that your transaction, your transaction in this case will not how will I put it? Let me put it well so that okay, there is no privacy when it comes to sending transaction in the network, you cannot say, this is my transaction, you want to mask it so that nobody knows what comes into your wallet and what goes out from your wallet. So please don't say that I said that in this session. Privacy in this case will mean that the metadata of your transaction, in this case, your IP address and all other addresses that is tied to you, probably the ones that you send to, you can have more than one account, right? If you're using a third-party provider, they can actually log all of these records on their backend, right? They can actually persist this record to know the distribution of all your accounts you operate and your IP address, right? So tying multiple accounts to you and your IP eventually. So you don't want that to happen, right? So when you run your own node from your terminal, I will show us how to do that when we get into setting things up. So yeah, so this is just the basic, just to give a theoretical background before we start going into running the commands and other things that will make us proceed today. So yeah, so that is the second point. Fourthly, the goal of blockchain is to be decentralized. Decentralization in the sense that nobody can prohibit anybody from accessing the network, and the network is not controlled by a single entity, right? No single point of failure, right? And that is one of the benefits of client diversity. Some of us will be wondering, like I mentioned when I was describing the different categories of clients, right? For the execution clients, we have Go Ethereum, which is the most popular. We have Netamind, we have Red, we have Erigon. All of these are different implementations. That means if one of these fail, the other ones kind of like will sustain the network, right? And again, not one entity, right? Let's say in the case of Ethereum Foundation, they are not the ones holding the network, right? Every other person running their nodes are also part of the network. If you just set up your computer, download both consensus and execution clients on your computer, you're running a node and you're part of the network if you're a validator, right? It's kind of like all the reliance on centralized entities diminishes, right? It helps to promote the network health, security, and operational resilience, right? So yeah, so as more people run their nodes, reliance on centralized points of failure diminishes, right? And the network resilience is achieved, right, with more nodes, especially in geographically diverse locations, such as we are in Africa, right? So basically that, the more the merrier. That is the goal of running nodes. Yeah. So I don't know if there are questions. Otherwise, I'll continue. Right. Then sovereignty. You own your network. You own the way you want. You don't need the way you want it. You own it. Right. So when you run your node, you have exact copy of what is happening on Ethereum. On this my node here running, I have on mainnet everything happening on Ethereum. I have it here. Nobody can actually censor me. Nobody can say there are copies that I don't have access to, right? It is distributed amongst all the node runners, right? Each of these nodes in the network is considered a peer, right? I am my own. I own the network. Anything I need in the network, I can actually retrieve that data. I can actually write to the data. Nobody controls anything concerning my access to the network, right? I hold my private key, and with that, I can actually send transactions, right, directly. So basically, I don't need any third party, right? So that is the promise of sovereignty that running a node guarantees you, right? And again, public RPC, I can actually provide access. So what we do when we write our smart contract, when we want to integrate our front end, can you guys hear me? Hello, guys.
Yeah.
Sure. All right. Thank you.
Yeah.
So yeah, nice. So the RPC we provide when we run nodes, nobody can censor you, right? So like I was mentioning, right? If you are you've written your smart contract, you want to integrate a front end, basically what you will do is to go to Alchemy or Infra, and then they give you an API key that you can actually use to interact with the network. If you run your own node, you don't need any of those things, right? You are your own RPC. You just make a call to localhost port 8545. This port 8545 is the port that is running on your locally on your machine. What that means is you own the network and nobody can censor you. You can actually send transactions. You can actually send people access to this your port 8545 of your IP address, right? So that they can actually make calls to the network using that. So it's going to be, so ideally, what a typical RPC is like is the IP, then the port, right? In this case, the IP address, let's say your IP is 0.0.0.0.0. We know that is not really an IP address, but then port 8545, because that is where your execution client is exposing all the JSON RPC methods that anyone trying to access the network or interact with it will make network calls to. So what all these RPC providers like Alchemy, Infra, what they do is to kind of like assign an individual account to an API key. So that's kind of like gives you access to the network, right? And they can actually log all of your requests and know all the metadata of all the transactions you're sending. It's not hidden, right? If, for instance, any government in the world wants to figure out all of the things you are doing, and they know your email address, and you know you are a developer, right? They can actually issue a warrant to most of the node providers to probably, with this your email address, get all the transactions you have ever conducted using their RPC, and they will give that government entity those requests, right? So because it's kind of like persisted on their server. So that is one of the disadvantages of using all these third-party RPCs, right? So with your own node, you're targeting your local host at port 8545, and you can actually make any request to read and to send transactions, right? So you can actually use directly from your CLI, right? You can actually use Cast. So you can actually use tools like Cast. Cast. This is so Cast is I think I don't know. Guys, can you see my screen? Let's say Foundry. So you can go to Foundry Paradigm. So yeah, I don't know why this is shutting down, but let's say Foundry book. Foundry book. So basically, you can actually come here. So yeah, installations. You can actually come here. I think a lot of things have changed. Cast, yeah. So overview reference. You can actually see. You can use. So Cast is part of the components of Foundry, right? Using Cast, you can actually run a lot of commands, right? From your terminal, you can actually run there are a lot of commands here you can actually use. Cast, send, all of those things, right? You can actually use this to interact with the network directly, yeah. So you can actually send a transaction using this command. So very easily, you just do this. Simple. I think there are so many instances. I think we'll do that. Let's not focus too much on that. But basically, what that means is from your CLI, right, your terminal, you can actually make network calls. You can actually read any data. You can actually send transactions just from your CLI, right? So without relying on any third party. Basically, one of the things that comes with running nodes. I don't know if there are questions, so that I can actually proceed in the next thing. So now we have said a lot of things, but because of time, right, we'll be going into the meat of this session, which is opening. I'll be sharing my terminal, and I'll be doing all the necessary installations. I don't know if there are questions. Please let me know those questions. Hello, guys. Are there questions? All right. So I think if there are no questions, let me proceed, right? I don't know if there are questions. So let me do a recap, right? So I started this conversation today by talking about what a computer is, right? I said before that a node is a computer running Ethereum software. What is a computer? A computer is an electronic device that has access to what? Storage, memory, and CPU, right? I said again that any computer implementing an Ethereum client is an Ethereum node. So we have two types of Ethereum clients. We have the consensus client and we have the execution client, right? And these are the responsibilities, like I mentioned, right? So these two components interact using what we call engine API at port 8545. So basically, they interact and exchange information, right? All of these things, we will see how we'll do that, setting it up right now in the next session. So yeah, as I think I mentioned the very important part, right? Is it every computer that will run a node? The answer is no, right? What are the hardware requirements to run a node? So I think let's cover that before we start hardware requirements. I think, yeah. So yeah, not every computer will serve as a node because there's what we call IOPS, right? IOPS is input output operation per second, right? The IOPS of it's just like somebody wants to travel to Lagos from Abuja, right? And you want to use a Beetle to go to Lagos. You spend days on the road, right? Somebody trying to use a Ferrari will get to Lagos faster than you trying to use a Beetle. I'm trying to use these analogies because we can actually relate to it, right? In the same vein, you're trying to perform computation-intensive operation, right? That is reading and writing. And it matters to a great extent what the tools you're using to perform these IOPS, right? In the case of the specifications, right? These are the specifications that you will need. You need a CPU because I mentioned earlier that a computer is a device, an electronic device that has CPU. So what kind of CPU we're using, right? The central processing unit will be minimum of 4+ cores, right? Which is the ideal thing. So if you're running an Ubuntu machine, you want to kind of like do something like this, ls. Okay. So you comment. So yeah, so you want to do, let me clear this. So yeah, you want to do something like ls CPU. So ls CPU is the command. I don't know, can you see my terminal? So with this command, it will tell you the specification of, in this my machine, this is one of my small machines. My other one, because of this is recorded, I'll not use it. So this cause is what is specifying, right? The minimum is 4 and upwards. I think my other machine, I think it's a 6+ cores machine, but I'm not using it for this tutorial, right? But minimum of 4 cores. That is what you need basically, right, to run a node, right? So from 4 upwards, it's okay to run a node. Anything lower than that will affect the processing power, right? And again, you need very, very efficient RAM, right? Although in some documentations, you will see something like you need like 8 gig, but ideally, if you want to run, probably you want to run multiple stuff, you will want to use, let's say 16 gig plus RAM, that's memory, right? Then the next thing is what? Storage. Please, when running a node, this is very, very important. There are so many types of storage devices, right? I think you don't need a HDD. So because why is it necessary? Because the execution client relies heavily on IOPS, right? Like I mentioned, operations per second, right? And this is recommendation, right? 15K read IOPS and 5K IOP in practice. This means that HDD, if you have an HDD storage, it will not work, right? It will not have that intensity, right? Then let's say storages like SATA and all of these categories will not work. What is kind of like recommended in most documentation is an NVMe SSD drive, right? And again, there are different categories. I think we have TLC, we have MLC, and SLC, right? Anything from TLC. So don't use QLC, right? That's quad level cell. Don't use that, right? Use TLC. That is, I think, tri-level core and multi-level core for 2. The high-end ones are the SLC. That is what a lot of people use in their server, and it must have a drum catch, right? So that it's kind of like resilient enough, and it will last for a long period of time, and it's easy to retrieve data from it. Basically, that. right? So yeah, so that is basically all of the things you need, right, to run a node. Make sure that your machine, the CPU is a minimum of 4 plus cores, and then the RAM is 16 gig plus, and then the SSD minimum of 2 terabytes. So now this is very, very important, the size, right? Why is the size important? So it depends on the network you're running it on, right? On Ethereum, right? If you want to run mainnet node, I think this works. But as the network grows, right, you may want to kind of like increase the size of your SSD. Right now, with a 2 terabyte, you can actually run a full node on Ethereum, right? But if you want to run like I would encourage, if you kind of like, if anyways, the higher the capacity, the more expensive, right? So basically you want to also consider your budget, right? But if you can actually afford a 4 terabyte SSD, right, make sure you can get that, and that will serve you, right? I don't know if there are questions, like I've recapped earlier. A node is a computer running on Ethereum software. We have two categories of this Ethereum software or Ethereum client. We have the consensus, and we have the what execution, right? And I mentioned that each of these softwares are implementing for the execution ones, they are implementing what we call what Ethereum execution specs, right? So for you to implement that, any software implementing that automatically is an execution client, right? And we have a number of them. We have Netamind, we have Get, we have Erigon, different ones based on the implementation, the language they use to implement them. And for the other ones, on the other hand, we have the consensus. We have, yeah, somebody wants to ask a question. Naomi, please do.
Okay, hi Dave. Well done with the explanation so far. It's been straightforward. However, I mean, for the hardware requirements that you've listed, does this also cut across the stack node, or just anyone that just wants to run Ethereum?
Come again, I didn't hear you.
So if we want to run the stack node, of course we know this one, Ethereum is sort of like is heavy work. So definitely, like, we need something that is like that can handle that capacity. So if we're going to run stack node now, do we still need this level of heavy duty like machines to be able to run it?
Yes, because look at it this way, right? Ethereum is, for you to run a Starknet node, you must run an L1 node. There's a reference to, we're going to see as we start setting up our environment, running the commands, we'll see it, right, play out. So it's like a story building. The base ground level is Ethereum. So at the end of the day, at this point, for you to run a Starknet node, you must first of all set up what? An Ethereum node. So an Ethereum node must set up, and this comprises of one, the consensus and the execution, right? So if you want to run anything on top of it, right, that means you need extra. So this is kind of like the minimum, right? For mainnet, I don't think you will scale very well with these 2 terabytes. I think you want to go for something higher, like 3 terabytes, 3 terabytes, because you will run out of disk space, especially because I'm specifying because of disk, because it's very, very crucial, right? Is the disk space. So if I don't know if I can actually show my screen here, I have a 2 terabytes here, and I'm almost 81%. I've used 81% for Ethereum mainnet. So you can imagine a layer 2 solution, right? So you have the ground level and the next level. So that means you must, as the chain grows, so will the data grow. So you will kind of like run out of your disk space, right? So that is why it is recommended to kind of like, if you're going to run a Starknet node, use, I think from the documentation, I think it's clear. We're going to check out Juno documentation, but I think let me do that. Juno, yeah. So let me go there so that we can actually know hardware requirements. So yeah, so they're saying RAM is 4 gig, storage 400 gig, 400 gigabytes, right? So that means with what I have here, almost filled up on mainnet, that means I may not be able to, if I have used up to 81% running a node on mainnet on Ethereum, that means I don't, this will max out. right? I'll run out of space for me to run a Starknet node on top of what I have, right? So I think minimum of, especially for mainnet, unless you're going to run it on a different network, in this case on Sepolia, right? So 2 terabytes can actually serve. So dependent on the network. On Ethereum mainnet, 2 terabytes will not be sufficient to run a Stark node on top of Ethereum, because I don't think that will be enough. So that is why I'm recommending minimum of let's say 3 terabytes. Like, yeah, so if you're going to run it on mainnet. But for today's session, we're going to run it on Sepolia so that we can actually see how it works. It's just the same command and different flags to pass in while running it, but basically the same thing. If you want to migrate to mainnet, you just change the network, specify the network automatically. That is just the only thing you will change, and then everything will work as normal. So yeah, so I think that's, I don't know if that answered your question now.
Yeah, it did. Thank you.
All right, no problem. So yeah, so so this is where it gets kind of like interesting. I think some of us are really waiting for this moment, right? So yeah, let me. Can you see my screen, guys? You can see my screen. Can you let me know? Guys, the error I was having before, it was because I was in verbose mode. So if you know, when you do VVV, automatically you're in verbose mode, and that'll be sharing both your keystrokes. So that was why I had that error earlier. But I think we're fine now. So so if I see my screen, let me make it a bit more bold. So yeah, so let me see into my ETH node. So like I mentioned, right, for me, right, I try to like separate things, separate concerns. So we're going to run 2 terminals. One terminal is going to be for our Ethereum, what's it called, our execution client, and one terminal is going to be for our consensus client. But before we get started, something I want us to know that it is already installed on my machine. But if you want to get started, what I'm running on my my consensus client is what I mentioned earlier, Lighthouse. So I'm using Lighthouse. So we're going to go to Lighthouse, right? This is that official documentation. You can actually follow along. So I want to use documentation so that everybody can relate to what I'm doing and then follow, right? So yeah, clients, what's happening? Let me go to documentation. Clients. Yeah, Lighthouse book. Yeah, go to Lighthouse book. I think this is it. For those of us interested, let me try to drop it on the group. I think somebody has a question. Let me check and see. Yeah, we can see. Yeah, thank you, Joseph. So this is it. Go to Lighthouse, and then when you go to Lighthouse, you go to build from source, right? Build from source is going to give you all detailed information to get started, right? First of all, you want to install, make sure you have Rust installed on your computer, right? So you can actually install Rust using this command, right? This command is what will install Rust up. Rust up is the toolchain installer. So what that means is when you have Rust up, you will, after installing after installing Rust, right? When you install Rust up is the toolchain installer. So you are going to after installing Rust up, it's going to install Cargo, Rust C, that's the Rust compiler, and then other things for you, right? Automatically, you will have access to all of the things that Rust come packaged with. So Rust compiler is what you need, first of all, right? I mean, when you run this command, automatically it installs Rust up. So after installing Rust up on your terminal, you do just something like this. You just call, let's say, which Rust up. So it's going to show you, yep, which cargo, I think, yeah. But anyway, it's running on my own, but I don't know why. Let me see to CD into CL. So this is my consensus layer. So I want to CD into, so let me do journal ETL. So we're going to, don't worry, I'm going to explain shortly. -o -f, then cat -f -o. So yeah, it's running. So yeah, let me clear. But first of all, for you to install Lighthouse, you must have Rust installed on your machine. So yeah, let me go. Let's go back to installation, right? So after installing, then you will want to install this, run this command also on your machine. And once you have successfully installed that, you are good, right? Then we can actually clone this repo, because there are a lot of ways to install this, right? You can actually use Docker, but for me, I would recommend, right? There's what we call bare metal. Bare metal is using the built-in binaries, right? You're installing it directly on your machine, right? Without using Docker. You can actually use Docker to handle most of your installations, right? But the first thing, if you have Rust installed, you proceed to run this command, right? This will install a lot of things. It will install, so this is kind of like the basic tools, right? The basic development tools for you to use Ubuntu as a developer, right? You have Git, you have GCC, you have make. So if you want to make something automatically to run that for you, when you're done, automatically you're good to go. The next thing is to what? Clone the repo, clone Lighthouse repo, right? Once you have cloned Lighthouse, automatically you have that repo on your machine. You CD into that directory, then you check out automatically. It's always stable. So if I actually go to my let's say yeah. So let me CD into my Lighthouse, and let me do Git branch. It's always in the stable branch. Okay, the fact I'm in this. Okay, yeah. I mean, I think I've not really. But basically, once you run off this command, automatically it's going to show you that you are in this stable branch here. So basically that. But this is not the most important thing here, right? Then after you have done that, you run make. So make is going to run the make file, which is basically going to build the binary for Lighthouse to be exposed in your machine, such that when you do, at the end of the day, after that make command has been successfully run on your computer, right? Lighthouse binary is exposed on your part. So you can actually do which Lighthouse, right? Because I see it into it, so probably that. I don't know why, but basically it's supposed to tell you where Lighthouse is in your machine, right? But for me, let me clear my terminal. So once you have installed Lighthouse using all of this guide here, the next thing you want to do, right, is to you want to, let me do cd into the execution. You can actually create a folder. So what I do basically is to create a folder called Ethereum. Then under Ethereum, you create a folder, a subfolder called consensus, and on the other folder called execution. So for me, I'm using EL and TL respectively to depict each of these layers, right? So for me, I've left the execution, I've left this consensus layer. I'm now in my execution layer. So that is it. Eventually, if you have successfully installed Lighthouse on your machine, right, you should have, when you run which Lighthouse, it's going to show you the part where the Lighthouse binary is in your machine. Basically that. So yeah, so for the consensus layer, you have Lighthouse installed, and we want to also, on the other hand, install what? Ret. That is for our execution layer. So we can actually visit this documentation here. So quite straightforward, just like what we did earlier. Go to, so first of all, these are implementation of, I like Rust, right? So for the execution layer, Rust client, in this case, Ret. For my consensus layer, a Rust implementation, Lighthouse. So basically, I have this installed on my machine and I'm good to go. So the same thing they're saying here, you must have installed Rust, and then after installing Rust, it will give you and you do Rust up. Sorry, you must install Rust up using this command. So Rust up is going to give you access to all of the components that make Rust powerful. So they can actually use the respective binary that is bundled together under Rust up. So that's going to give you access to Cargo, which is the package manager. That's going to give you access to Rust-C, which is the Rust compiler, and other things that Rust has packaged together. I think there's a document component too. So yeah, so when you have that, you are good to go. The next thing you're going to do is to just run this command. So what this does is to clone the ret repo into your machine. Then you feed into that repo, right? Once you have done that, automatically you are good, right? You can actually install ret by doing cargo install. Remember, cargo is exposed to you when you install, when you do rust up, right? After installing rust up binary on your command, you do rust up. Rust up will give you access to cargo and rust-C, right? Then with this cargo installed, you just run this command. Automatically, it will expose, it will build the ret binary and expose it to parts. That is basically what this command is doing. Such that when after running this thing, when you do ret dash version, you will I think ret dash version. I don't know why mine is not okay. Yep. CD into ret. My ret is actually exposed to parts, right? So what I did for me, right? There's what we call system CTL, right? I actually enabled the service such that immediately my computer ons, it will run this service for me. So let me expose that. So let me do sudo vim /etc system d what red.service. So this kind of like will show I think not here. I think something is missing. I think the command is not okay. I think system D then rest of service. Oh yeah, this one's it. Yeah, so yeah. So basically, what it's doing is it's pointing to here. This is where I have my binary, right? So let me copy this command and exit here. So we're going to talk about this later. So basically this. So we're going to explicitly talk about the command here and what it's doing, right? So what I have here is that I have in this my computer, right? I have exposed my binary. This is where I have my red binary, right? My red binary is under my cargo. So when I do, I think, let me try to. So basically, what that command is doing for me is that it's pointing to where my red binary has been installed. And basically, it will enable me to point to how I want to run. I think I can actually paste it here. So let me do that again. Let me do sudo vim /etc /systemd. So my system daemon. So yeah, system /red.service. So yeah, so this is the command basically that will run my red. So let me copy this. And then let me exit. Yeah. So basically this is the command, right? So to run your red, you need this command. So let me do this. Let me go here. Let me also, I think I'll be sharing this too, so that anybody that wants to run their red will use this to set up their red. So yeah, so to run red, yeah, so this is the command. To run red, So yeah, so we're going to explain all of this in a minute. So just give me some time. We're going to explain that. Also, I want to also run Lighthouse. So anybody here interested can actually go through that. So yeah, so run Lighthouse, that's this. So yeah, copy. Yeah. So let me go back here. My consensus. I don't know if you have any question, please feel free to ask your question. I talked about consensus client, execution client. Yeah. So, yep. Run Lighthouse consensus client run use this command. So I'll be sharing this documentation so that if you want to do that, you can actually follow along, and it's kind of like straightforward. So yeah, so I'm going to explain. So yeah, so what is happening here? Let's talk about the Lighthouse. I think I didn't explain this part. So yeah, so basically when you have successfully installed, let's go back to their documentation, right? You see the into Lighthouse, you run make automatically. It's going to build the binary and expose this to power. That is what this command is going to do, right? It takes some time. It takes some time actually, right? So when you have that and you run Lighthouse version, it's going to show you the version of Lighthouse you're running. Now you're set to run a node. What is all of these things that I've pasted here? Now, one thing I want you guys to know is that the Lighthouse is the binary that exposes all of the methods and all of the functions that Lighthouse consensus client can run on your machine. So this BN means beacon node. So under the consensus client, there are two things. We're going to learn about them, right? We have the beacon node and the validator client, right? As far as running a full node is concerned, we don't have at this point, we're not running a validator client for Ethereum, right? We just want to like run an L1 node, right? So we're going to run the beacon node, and this beacon node is going to talk to our execution client, right? So basically that. So inside the consensus client, it is further divided into so many clients. We have the beacon node. This is the component responsible for spinning up a beacon node on our machine, right? I'll specify the network. In this case, we're going to start off with Sepolia, right? This execution endpoint here is the engine. Remember I mentioned engine API, right? In the course of my talk earlier, I mentioned engine API, and I said that in engine API, it's the point of interaction between the consensus client and the execution client. Remember, we're trying to install Lighthouse, which is a consensus client, right? So yeah, so basically, I'll share this documentation. So yeah, so please allow me to explain. Let me explain, guys. We're going to see it in action, right? The network, Sepolia, this flag must be there. This is the engine API, referencing the engine API, which is our local host in port 8551, right? And the JOT, let me go back here. So some of us who really are coming from backend background, right? You know that JOT is how you kind of like authenticate users, right? So yeah, so there's supposed to be some form of authentication between the consensus layer and the execution layer. In my own case, like I will show you guys shortly, right? Where's that? Command Lighthouse. So yeah, in my own case, this is where I have installed my, you need to kind of like get a jot command using, I think let's go to this documentation. Yeah. Let me search hex. Run a node. I think it's here. So you must specify where you want to have this jot command. So yeah, so basically this. So using this, you will specify where you want your jot, right? This is kind of like a hexadecimal, right? So this this kind of like randomly generates a hexadecimal, right? And this is the part. For my own case, I'm not using this secret.hex. You can actually call it anything you want to call it, right? In my own case, I'm calling it what? Jot.hex, and it's in my ETH node, right? And basically that. So that is where, if let me go there. I think it will not be necessary anyways for this call. I cannot expose it, but basically you can actually save it anywhere and expose it with this command, right? So this is where your beacon node will be looking to get the hex value that is going to serve as the communication link between the execution and the consensus, right? So it needs to know that it is really the execution client that is interacting with. So yeah, so this is kind of like how to do that, right? So yeah, you specify the part where you have that jot in that hexadecimal. Then this checkpoint sync. So this checkpoint sync URL, what is happening here is that checkpoint sync URL, you may not want to download the entire state of the network, right? So you want to download from particular checkpoint. So there are a lot of people, there are a lot of providers, right? If I go to checkpoint, so there are a lot of checkpoints, right? So this resource here provides most of the Ethereum checkpoints that you want to and the different networks, right? In my own case, I'm using, so basically this, so a lot of people have provided public goods, right? You can actually specify them as a checkpoint so that if you don't want to download probably everything, you can actually specify from this checkpoint and it's kind of like syncs, your node will sync faster. That is your consensus layer, right? Then after that, you specify that it is what you will accept requests that are specified as HTTP. I don't know if that, okay. Do I need hardware requirements described previously? Yes, you can actually use a VPS, right? So yeah, you can actually use third party. Some people can actually run this on their cloud server, like GCP, Azure, AWS. You can actually do that, right? Or you can actually do it on a dedicated, we call it a bare metal. Where's my, so yeah, so this is the kind of node I'm using. Let me show you guys. So yeah, so this is a computer. I don't know if you can see. So this is a typical computer. Basically, this computer has a memory, it has a storage, and so yeah, so this is the computer. Let me show you the drive. So yeah, so you need this kind of stuff. So this is the SSD. I don't know if you can see. This is basically the SSD. But I'm not using this one because of the fact that this is kind of like not up to standard. This is 500 gig, and we're talking about over 2 terabytes. So that is, you have this device, this computer, which is my PC, right? A dedicated mini computer with this. You attach this disk to it. Automatically, you can actually run this software. So to answer your question, you can actually use a VPS, but this is what we call a bare metal, right? If you install all of this on this machine, you're running a bare metal. You're running Ethereum node on bare metal. Basically, some of the things that you will be seeing most of the time. Some people will say that they're running bare metal. Let that not confuse you. That is just basically what I showed you here. So yeah, so HTTP will enable you to make HTTP requests to your node, and this lighthouse attaches itself to port 9000, right? So if you want to make requests to this node, you will want to go to port 5052, right? That is the port to access all of what the beacon node has in stock for you, the beacon node you're running on your computer. That is the consensus layer, right? And this is the address. And in this case, this is, I think this disabled deposit sync contract. Yeah, so I'm not running a validator client on Ethereum, right? But I'm running on Starknet. So if you pass in this, if you're not running a non-staking node, a non-staking beacon node, you add this flag. So yeah, that means that you don't want to be stressing your beacon node to be checking for what's it called, if you don't want to run a validator client, that means you don't have 32 ETH. But let me clarify, right? Ethereum is not decentralized when it comes to Sepolia network. Sepolia network is a closed network operated and managed by the Ethereum Foundation dev team, right? The core engineers managing Ethereum are the ones managing Sepolia. You cannot participate as a validator on Sepolia, right? But in other networks, you can actually do that on Hoodie, which is the new testnet, and on mainnet, right? But for Sepolia, you cannot be a validator. So yeah, so you always specify. Remember, we are doing this on Sepolia. So yeah, we're going to learn about epochs and slots. So Ethereum has what we call epoch and slots. That means every 12 seconds, a block is created by a validator, right? A validator, we're going to talk about validator later. Let's not deviate. So yeah, so basically that. So that is with that command automatically it will. So let me do journal CTL. So this journal CTL, this command I'm running here means that anytime my PC turns off and turns on automatically, it will automatically run my red and my lighthouse, right? I'll show us how to do that, right? So if I do this and I do lighthouse and I do F, real-time logs, and I do -O and cat to format it. My node is running actually, right? It is fully synced. You can actually see it here. It is synced. So when you run this command, right? If you run this command, automatically you have something like this running on your computer. So this is one leg of the puzzle. You are successfully running a consensus client on your computer. Now let's talk about the next one. The next one is what? An execution client. I don't know if that makes sense. So for you will want to run on another terminal your execution client. This terminal is for your consensus client. You're going to open another terminal and run your execution client. So something like this. So you want to come here and say next. So yeah, will come here and run a different command for setting up what? Your execution client. I don't know. Yeah, so there are no questions. So let me continue. So yeah, so let me, yeah. So let's go to this guy. So what is happening here? Remember, I mentioned that to run an Ethereum node, you need two things to run. You need a consensus client and you need an execution client. We have successfully walked through how to install and run our consensus client. The consensus client of choice in our case is what? Lighthouse. In this case, if you want to run an execution client, you're going to run any one of them. You can run Go Ethereum, you can run Netamind. Go Ethereum is written in Go, Netamind in .NET, C#, right? What's it called? Vesru, which is a Java implementation. Which other one again? Ret, which is what I'm going to run, which is a Rust implementation, right? And we have Ethereum JavaScript, but it's not production ready. But there's an implementation of Ethereum in JavaScript. We can actually run that, right? So yeah, so basically that. So when you run this command, automatically, let me break these things down, right? Ret is the binary that you have installed. That means if you run which ret, that means automatically, let me go back to my terminal. Let me have to terminate this, but that does not mean my node is running, right? If I stop this thing, my node is always running, right? This shows that my node is fully synced. Look at it, right? New block has been received, and let's talk about them. And it's connected to 37 peers. That means other nodes, right? It's in slots. So let me explain what's happening here. Let's go to the beacon chain. So yeah, so my node is running cleanly. So let me explain what's happening here. So yeah, so I showed something earlier. I showed something earlier that we have what we call we have slots and we have epochs, right? So this thing here, let me explain it. And to show you that my node is fully synced, right? The latest epoch is epoch 369501. Let's check. Let me run my lighthouse again. if you check very well, you will see that, okay, for Sepolia, so sorry, this is mainnet. Let me go to Sepolia. Sepolia, I think, yeah, Beacon chain, yeah. That's for mainnet, sorry guys. So yeah, so this is the latest epoch, right? If I check here, you will see that this is epoch 242132. The latest epoch here is what? 242132. And the latest slot is what? 7748249. The latest slot, let's check the latest slot. The latest slot is what? 774. Yeah, I think this is 250. So so if I refresh this page, the latest slot is 250. So that means my Sepolia node is fully syncing, right? And it's going to be incrementing. So a node, my consensus client is fully synced with the real-time updates in the network, right? So what is a slot? A slot is the time it takes. Every 12 seconds, a new block is created. So this is kind of like a visual representation of that. So look at it, right? So every 12 seconds here, let me try to minimize this. Every 12 seconds, 0 to 12 seconds, a new block is created. Every 12 seconds, and again, this distribution of the nodes that are currently in the globe, right? In Africa, we can actually see that we just have 4 people participating in running nodes, and I'm one of those people. 2 of my machines are here. So I'm actually exporting my data to ETHPanda Ops. ETHPanda Ops is the dedicated Ethereum core engineers managing this tool here to see all distribution of nodes across the globe. So yeah, we can actually see every 12 seconds a new block is created from 0 to 12. This is what is happening in real time. As it's happening, we're getting those updates, right? So yeah, to go back to the node, right? The latest epoch now is epoch 24. So what is an epoch? An epoch is what? 32 slots, right? It takes 6.4 minutes for an epoch. An epoch is 6.4 minutes because 12 seconds is 1 slot. 32 slots is what? 1 epoch. So yeah, you do the maths. So basically my node is syncing so well with the network. So let's go to the next thing, which is how to install RETs. So like I mentioned earlier, let me close this. Clear. So yeah. When let's go here. Where's my So I was talking about. Okay, I think let me go back to my RETs. So yeah, so this is the binary. Node means which it exposes you to which node you want to run on which chain on Sepolia. So this is, remember that 32 hex that I generated earlier for my I think I talked about it here. So yeah, so where is it located? That is what this command is saying here. This flag, this auth RPC. Where is that? Where is this? Where can you find it? Right? Sorry. So yeah. So if you run this, automatically it will run it. It will generate it on anywhere in your computer. But in my own case, I'm saving it here, and it's in my ETH node, and it's the same place where my lighthouse is pointing to, so that it's pointing to the same jot, knowing that it is kind of like coming from so that both of them can communicate together. Then this auth RPC address is my local host, right? All of us are developers who understand this. In 127.0.0.0.1, sorry, is localhost. This port, this is the engine API port, is going to connect to my engine API, right? And it's allowing HTTP requests. Without this flag, right, I cannot access my using HTTP, I cannot access my execution client, right? Make sure you pass in this flag. Then this flag here is the address. So automatically it's treating this as my local host, right? And again, you must specify the port so that this port in this case is kind of like external port. Remember, this one is different from this one. This port RPC port is the port for the engine API, right? This is different from this. This is external. So if you want to interact with your, what's it called? So there are 3 attachments. Your red attaches itself to what? Port 3033. It attaches to the engine API at port 8545. Then if you want to expose, if you want to call, if you want to access your, if you want to kind of like send transactions, switch transactions, you must specify the port, right? So if I call my machine on this port, I can actually access anything I want to access, right? Basically, right? And you must have what we call what WebSocket enabled. So this WebSocket is what will enable us to what run a StarkNet node. Without this WebSocket enabled, we will not be able to run our StarkNet node. So very, very important, right? We must have this, we must specify this flag, right? This is WebSocket, and this is the address. And Juno, after this, we're going to start running our Juno command, so we can see how to run a StarkNet node. Running Juno, configuring Juno. So Juno is always listening to what? Ports. You must specify your WebSocket port, right? So let's talk about it. Running Juno, yeah. So Juno is listening to ports. So outside this, where's my standalone binary? Yeah, you must specify that it must listen to ports. I think I have it in this. I have it here. So yeah. So yeah. So you must specify this. This is very, very important. If you don't specify it, your node, your StarkNet node will not run because it wants to communicate to your what's it called, to your execution client, right? At this port. This is the default port at port 8546. Whereas if you want to interact with your ret, it is 8545. So basically that. So yeah, so please note that. So we're going to see if you have successfully run that command, automatically you are good to go, right? So this is our ret. So no, sorry, that was not our ret. That was our lighthouse command. Let me check for our ret. Yeah. So let's check my ret. Ret. So yeah. So this is the command to run our ret. So let me paste it on the chat so anybody interested can run that. So yeah. So with this, you're good to go. And I'll also share this resource. Let's see how that command will run, right? So yeah. So automatically, I have my ret installed. And just to visualize, if you run that command that I pasted, if you do this, right? So some of us will be wondering, what is this journalctl, right? This journalctl is a way to visualize all the logs that is happening real time, right? I have my rets installed, right? So what is happening is I created a service, a daemon that is listening for, and immediately my computer turns on, right? I turn on my computer, it is going to automatically run my what? My ret and my lighthouse, right? So I'm running a full node anytime my computer shuts down by whatever reason. At the instance it comes on, it's going to automatically run my ret. So yeah, but if you have run that command, automatically you will be able to see this, right? So this is my ret running, right? It is running real time, showing how transactions kind of like are bundled and the fork choice. We will talk about this probably in subsequent times, but the goal is to run our StarkNet node. I will spend some time trying to explain some of this logs so that we understand what is happening, right? Yeah, the canonical chain number, all of the transactions in a particular block, all of that can be seen because in addition to anything I'm doing VVV right? Oh yeah, thank you so much, Naomi and Josh Busa. Well explained. So yeah, so basically this VVV, some of us were wondering what is that. That VVV is kind of like a verbose mode, right? You want to see extra details for each log, right? For each block created. So for each kind of like each fork choice and all of the things that is happening, all of the other peers, these are the metadata you want to get to understand, right? So yeah, so basically that. So let me terminate this. So we have our full node running. We have Lighthouse, and we have Lighthouse running. We have let me clear my terminal. So we have Lighthouse running. We have Red running. Our execution, sorry, our consensus and our execution clients are running concurrently, right? So yeah, they're running simultaneously. Like they are good, like yeah, in real time. Now, what is the next thing? The next thing is to what? Run a Starknet node. So the essence of this session today is to cover how to run a Starknet node. The next thing you have to do is to you set up your red and it's listening to so please don't mistake what I'm saying, right? If you set up your Lighthouse, which is your consensus client, it's going to listen to port 9000. If you set up your red, it's going to listen to your machine on port 3033. That's the default port. If you want to access your execution client, that is your red, you must pay attention to what port 8545. Now, port 8545 is the HTTP port for you to make requests to that server. Probably if you want to, from your CLI, want to like send transactions out, you target that port and you can actually read data, you can actually send data out, right? Now, the next thing we're going to do is to make sure that our, like I mentioned earlier, we make sure that our port 8545 is open using WebSocket. So this WebSocket is very important because without this, we cannot run our Starknet Juno node. For the presence of this session today, we are running a Starknet Juno node, right? So now, what is a Starknet Juno node? Starknet Juno node is a Go implementation of a full node on Starknet, right? Remember, like I mentioned, Starknet is an L2 leveraging Ethereum as L1. So these two must synchronize, right? We have an L1, we have an L2, and both of them must synchronize. So basically, that's basically what you need to run an Ethereum node, right? So yeah, I don't know if anybody have any question at this point. I want to take questions so that nobody's lost. So yeah, okay, no questions so far. So yeah, what is the next thing you're going to do? You must make sure that your port 8546 is open on your execution client, on your red. You can actually, if it's on your get, make sure that your port 8546 is open, right? So that you can actually make WebSocket interactions on your execution client. So basically, that's how it works. So the next thing that we're going to do is to, so we're going to, let's visit this resource. So yeah, so this is Juno is a NetaMind built Starknet implementation, Starknet client implementation, right? It's a Go implementation. It's written in Go, right? So this is the latest version. So now to install it, what do? You go to this repo, right? Go to NetaMind/Juno, right? They have their documentation link here, right? So yeah, so this is it. What do you need to do? I think this is clear enough. I don't know if this is clear enough. So yeah, you should have a full node on Ethereum, right? For me, I'm using that, but you can actually use a third-party node. But for me, I'm running everything from ground up, right? So you need a fully synced L1 full node, and you must make sure you install anything. Go, you must have Go binary installed on your machine, such that when you do Go version, and so you have Go, you have Rust installed, you have C compiler, and you have Gemalloc memory allocator, right? So automatically, if you have that, you're good to go. Then make sure you have run this command, apt-get sudo update, like sudo apt-get update, then this install the build essentials. We have already installed that earlier. Then you proceed to build from scratch. So you git clone the Juno repo, you CD into it. What's the next thing? You're going to build the binary, but make sure that you have make installed on your computer. Otherwise, you cannot be able to make anything, right? You CD into Juno, and then you start. So yeah, so let me do justice to that. I don't know if anybody have any question. Let me know. So I want to CD into. Let me play my terminal. CD to Starknet. So I SSH into my machine. I'm using my Mac here, but I've SSH into my remote server running, right? So yeah, so when I do ls, I can see you can see I have some binaries here installed. So I have Juno and I have my staking validator. So let's see how I can actually cover both of them. If we don't have time, can actually only cover just how to set up Juno, right? So basically that. So what do? We CD into Juno, and Juno is if we have Juno installed, we are good to go, right? So yeah, inside my Juno, I have kind of like a quick, I think it's still here, it's the same thing. So when it takes some time, when you do make build, it's going to build Juno. So you have Juno in your build, right? So when I do, let me clear, and when I do ls sorry, ls then al, yeah. So I will see that I have build. It's my Juno is inside this my build. So I will CD into what? Build. That's where I have my Juno binary. So this is the target for all of the methods that Juno has in stock for us. So basically that. So when you have installed, when you have compiled your Juno binary, which is available in this your build folder, right? You kind of like because we're running on Sepolia, remember, our L1 is Sepolia and our L2 should be Sepolia, right? It's the same thing. If you want to switch, you just specify the network name, nothing special. If you're running a node on Sepolia, it's kind of like easy to run on mainnet. It's just different flags that are specified. So basically, you're going to create a snapshot on your roots, and also this Juno Sepolia. So right, so basically where the database will be saved. Then the next thing is to run this command, right? So automatically, I have this already, so I will not be doing any of that. So let me show you. So let me see let me go out. So yeah, when I do vim, I think I have a run file, run.sh. So you can actually see the same thing I have here. It's not different from what is here. So let me explain, right? So this is going to go to this is an executable file, right? You can actually create an executable file so that it's kind of like easier for you to run it anytime, right? So what is doing is it's going into my build folder, and it's going to locate this Juno binary, which is what will give us access to run this node, right? And we're going to specify HTTP, which is meaning we need to make HTTP request to this our Juno server that is running when it starts running. It's going to listen to what? Port 6060. And this is localhost. This is the DB part, that DB part we created earlier. Remember, we created this DB part. So yeah, so it specified that DB part. Then each node. So this is the interaction between our L1 and our L2, right? So Ethereum as an L2 is going to leverage our L1, right? Remember, I mentioned earlier that we must expose port 8546. So this is what Juno is looking for, right? There should be a WebSocket connection between our RETs, right, and our Juno. Sorry. So basically that, right? And we'll specify the network, which is Sepolia. This is for metrics, so this may not necessarily add this, but it is eventually, if you're going to build dashboards, right, using Grafana and Prometheus, you'll see this necessary, right? I think yeah. So yeah, so basically that yeah, and our own port is on port. Our WebSocket port is on port 6061. So yeah. I'm not writing to this. I'm terminating this terminal. So yeah, if you run that command, automatically you should have Juno running. I have my Juno running, right? So I have Juno running automatically for me, and that will show you all the logs for Juno. So we can kill our Juno and start all over again. I can actually say sudo ls off. So I actually want to see if it is running because I have it running. Yeah, I think I do. I do have it running. So ls off port 6060. So yeah, I have my Juno running. Yeah, my Juno is running at that port. So I want to kill my Juno. So I want to do sudo kill 9 at port process ID 34 and run it from scratch so that you can see how it works. So yeah, if I run again, you'll see that no Juno is running again. So basically, so if I do this /run.sh, it's going to run my Juno. So if you run this command, automatically this is Juno running on your computer. You're running an L2 node, right? Which is in this case our Starknet node. So what is the benefit of running this Starknet node? I think some of us here are kind of like curious because this is the basic for us to come here. I want to learn, we want to understand what Starknet is all about. Because this session today is all about Starknet. So yeah, so this is basically our Starknet node running, and the latest block on Starknet is block 818039. So how do we verify this? We can go to StackScan and see that happening. So StackScan.co on Sepolia, we can actually switch Sepolia. Remember, we're running this node on Sepolia, so you can actually check this out running. So it's very easy. Let's check. Yeah, so I think mine is kind of like a bit, I don't know why, but this is the latest block 818043. So we have 818040. I think the next one should be 818 like that, incrementally by 1. So let's go to Voyager also and check. Let's check. Switch here to Sepolia. And then the latest block is 043. Do we have the latest block here? I don't know why my kind of like laggy, but this is basically how it's kind of like I'm following the network. Yeah, so what is the benefit? Like I mentioned earlier, I want to run yeah, so this is running on one end. So what do? I want to, so guys, permit me, I want to still create another instance. So yeah, so just one moment, so stop sharing. I don't know, are there questions so far? I want to take questions. If you have any question anyways, please ask questions. Truth, do you have any question?
No, I'm good.
You are following so far?
Yes, I'm following.
All right, no problem. So that's nice to hear. I don't know, Nomi, you have any question? Anybody with any question? Josh, you have any question?
Yeah, so I'm trying to sort of like install. I'm still at the stage where I'm installing Lighthouse. The network is quite bad, so I'm just trying to see if I can sort of like install the consensus and execution clients, and then so okay, maybe I should ask this.
Yeah,
so
sure, ask.
If I should install Juno, right? Do I still need to install Lighthouse?
So if you're going to build from scratch, yes, you need to install, first of all the components that make an Ethereum node to work, which is the consensus client, execution client, right? Yeah, so yeah, you have to.
Okay, but I can just install Juno and then it already has, so it works like ETH-Docker, right? Juno.
I think come again.
Does Juno run like ETH-Docker?
No, you may run Juno with Docker. You don't need, Juno is kind of like a separate binary that you run. So basically you have 3 terminals, right? You have terminal A for your consensus client, which is in this case Lighthouse. Terminal B, which is an execution client, in this case RET, and terminal C, an L2 client, in this case Juno, right? So yeah, so basically how it works.
No, so I'm asking, so if Docker sort of like has like most of the consensus and execution clients already installed, right?
Yeah.
So is that what Juno is? We can just go ahead and just spin up the node.
But I didn't hear you. Come again.
So if we install Juno, does Juno already have consensus and execution clients already installed in it?
Okay, yeah. So I get your question. So now on Starknet, there's nothing like execution client and consensus client. Everything is one. So Juno is just a full node running on its own. You don't need an execution client and a consensus client on L2. So what we have on L1 is consensus and execution, because Ethereum before it transitioned from proof of work to proof of stake was just one node. You don't need anything like beacon node or consensus node. No, you just need just run a node. In this case, Netamind, Go Ethereum. These are the popular, or Eragon. These are the popular Ethereum nodes that you could run, right? But because Ethereum transitioned from proof of work to proof of stake, now we have two different components. We have the beacon chain, right? What will make you to interact with the beacon chain is the what? Consensus layer, right? And the consensus layer, when you run it, it could be Lighthouse, and it must interact with what? Your execution client, in this case, VET, or any one of them. So basically, that is what you need to run an Ethereum node. On Starknet, there's no such divisions. There's nothing like execution client and then consensus client. No, you just run Juno, which is a full node in Go, right? We have another node in Rust. So I know, Truth, you like Rust so much, and you want to check out Pathfinder. I think in another session, we can set up Pathfinder and run it and stake, right? So yeah, so basically that. So on L1,
that would be cool.
you have two
I'll be
components.
expecting
Yeah,
that.
sure, we'll do that. It's a Rust implementation of Starknet node, right? On L1, you're running consensus client and execution client. On L2, you're running just one full node. And this full node in this case is what we call what? This full node is what we call what? It's what we call what? Juno, in our own case, right? We're running a Juno full node. So we just run it. It's not doing anything. The only synchronization between L2 and L1 is port 8546, right? This port 8546 is exposed remember when I said something like, right? When you're going to run the command to set up your, let me say my RET, yeah. So you must make sure you specify this, right? Am I correct? What did I did wrong? So yeah. So let me check. I hope I have my RET. Yeah, that's my RET. Yeah. So yeah. To run your RET, make sure you have. If you have this thing here, automatically. Let me close this. So automatically. So if you have this specified while setting up your RET, that's your execution client, you have exposed a port, a WebSocket that would serve as a linkage between your execution client and your L2 node. So this is what your Starknet Juno node is looking for, right? So if you have this, automatically you are good. It will start syncing. It will start downloading the history, and then you will start participating in the network. So yeah, I don't know. Are there any questions? I think somebody was asking a question. Sorry, I don't know. Let me.
Yeah. So thank you, David. So basically, what I wanted to ask, I think, I think Naomi asked it. Basically, I was wondering. So because I understand that when deploying, I've used Juno a lot. Yeah, because it's deploying on it is free. So what was confusing me is that when I'm deploying maybe my contract using Juno as the client, so I was wondering whether it embodies the execution and the consensus. That's what I was wondering. I was confused about. Yeah.
All right. Okay, thank you for that. I don't know. Can I? Okay. Are you asking a question?
Yeah, so maybe like you tried explaining it, but I didn't get it properly. So when does Juno have the consensus and the execution in it?
No, it doesn't. It doesn't.
Okay.
The only instance of consensus and execution is on Ethereum, right? There's no such thing on L2 as execution and consensus. So you just run Juno. Juno is just a full node, right?
Okay, thank you.
So yeah, so we're going to install something here. I don't know if that answers your question.
Yes, it did. Yes, it did. It did. Thank you.
Awesome, awesome. All right. So we're going to be using. I don't know. Okay, we're running out of time. I don't know. We've run out of time. So with this, you're running a Starknet full node. Where's my no? Yeah. So this is basically what a Starknet full node is. You're part of the network. You can actually. So I don't know if we have time. I want to install. Let me say this 1.2 by software mansion. Software mansion startup. Yeah. So let me install startup. Let me install this. So we're going to send a transaction on Starknet, right? And yeah, so let's do this. So let me do this. Let me run this. So yeah, so yes. So if you want to send a transaction to the network, this is all you need. Basically this, that's all, right? We will use this to create an account on Starknet, and we'll fund this account and use this to send transaction to the network, basically. So you don't need any third-party provider, you don't need Infura, you don't need Alchemy. With Juno node, you can actually interact with the network all by yourself. So once this installs, we will proceed to use it to send transactions. Who is excited about that? So we don't need third-party providers, right? So basically that, we'll see how we can actually use that in this session. So let me close this. So it's going to take a while. I don't know if we have more time, we can continue, but if we don't, because we said we're going to kind of like if I get a yes, we'll continue. It's supposed to be 2 hours, but so far so good. It's fun. Should we continue, guys?
I would say we should continue so we can finish it off.
Yeah.
All right, no problem. Nice. Oh, nice, awesome. So guys. So we're going to send a transaction using Starknet Foundry. So what is Starknet Foundry? Just the way you have Foundry on Ethereum, right? If you're building a smart contract, you want to interact with the smart contract you want to integrate it, like you want to kind of like do some integration tests, fork tests. You want to test an ERC20 token, you need an RPC URL, right? And also on the same time, you need to kind of like a framework, a building and testing framework to kind of like test your smart contract. That is what Forge is on Ethereum, right? You want to use SM Forge to test all of the functions you've written in your contract, and basically that. And if you want to interact with the network, you use what we call Wordcast. I was trying to like talk about it before now. Foundry, I don't know why this. Okay, yeah, so this is the main Foundry. So they have their book, Foundry book. You can actually take a look at it. So yeah, so on Ethereum, I'm talking about Ethereum this time, right? So this is the book. Let's go there. So basically, everything you need on the book is here. So we have the Foundry comes with Forge for testing and for creating a new project. It comes with Cast if you want to send out transactions to the network, if you want to read and write from your terminal, all from Foundry, you use Cast. Starknet Foundry is mimicking something like that, right, on Starknet. So we're going to use the documentation to see how it works. So yeah, I think it's successfully installed. So yeah, I need to run, let's say, which stackup. Okay, I think I need to run this. I need to run source. So this is to kind of like bash ROC. So if I run which stackup, I don't know why I'm not saying this, but I'm supposed to. I know I should. So yeah, if I run stackup, let me see. I have stackup automatically now, right? I don't know why it's not giving me the version, probably because I seed into it. I don't know. I SSH into my machine. So yeah, it gives me access to certain binaries. I have ASDF, I have Starknet Foundry, I have all of these things. We have them, right? And also, on the other hand, it gives me access to, I think, let me check. Let me say SNcast. SNcast, that's that version. Oh yeah, I have SNcast, nice. So we're going to be using SNcast to make transaction to the network. Please follow me, right? So I have SNcast, but I don't know if I say which SNcast, I don't know why it's not. Okay, yeah, I have it, nice. So if I do which SNforge, truth, you were in the bootcamp, so you will know what I'm doing. So if I do which SNforge,
Yeah,
I have it. I have all the binaries. So let me increase my screen. Let me even clear my terminal and so that it's clear. Now, what do we do here? I'm trying to do something interesting. Sorry, guys. So yeah, I want to do something interesting. I want to use the documentation. So I have been successfully installed the necessary binaries. So follow along. So we don't need any third party to transact on the network. So look at what we're going to do. So we want to create an account, right? I want to automatically create an account. So what I'm going to do, just copy this, right? And then come here on my terminal here and paste it, right? Instead of network, automatically it knows that it's network now so that it doesn't use, so I would say network U. I think my network is what? HTTP/localhost. I think when I created that account, what did I point it to? I said I want my Juno to run where? On port 6060, am I correct? Yeah, port 6060. So I'm going to say what? What? 6060. And let's call this account, let's call it session 1. Session 1, right? Let's do this. Nice. Can you see? Automatically, I've created an account. And this command here, -u, means my URL, my RPC URL, right? I want it to create an account using my RPC URL. My RPC URL, if I do call, I think -v, HTTP local/localhost, then 6060. Yeah, it is okay. It's returning okay, right? Meaning I can send requests to my port. This is the port where my Juno is running. So I can actually do sudo lsoff and -i, and I do what? Port 6060, and what is it saying? It's saying the port, this process ID, right, in this port is process 6934, and the process running on that is my Juno. So basically, meaning that I can actually use this port to send, this is my RPC. This is RPC, all the RPC you've been hearing, what you create when you go to Alchemy Infra. This is basically what is it, right? Your local host port 6060, right? On layer 1, it is localhost port what 8545. So let me run the command again for my Ethereum, right? If I go to 8545, okay, okay, no, I'm not trying to ping it. I'm trying to say, let me clear my terminal. Oops. So if I do sudo lssolve and I do then I do 8545, you can see my red, it is my red that is running on this process, right? This is the process ID and my red. If I kill it, my red is automatically killed. But this is not the core goal of this what I'm trying to do. I want to show us that at my port 6060, it is returning that Juno is running. That means this is my RPC. I think I mistakenly cleared off that command. So then we're going to create another one anyways. Let's call it what? Let me call it truth. Truth. Let me use your name. Permit me. Can I?
No problem, sir. No problem.
Oh, yeah, no problem. Oh, yeah, no problem. Let's call it truth, right? So I want to create a new account called what? Truth. So I see it has created this account. So this account, this is the account. And what happens? How do we know that it has created this account, right? By default, all accounts created by SN casts, right, is when I go to cat, let me cd into, please, this is for test. In production, don't do this, right? Starknet, I think accounts, yeah. Don't do this in production. Don't do this for serious money. Otherwise, you will lose your money, right? I want to do cat. So you can see that automatically when I run this command, we have this JSON file. This Starknet, all what's it called? All SNcast accounts are implementation of Open Zeppelin accounts, right? So this is a JSON file where you can actually see all the accounts that I've created. So I can actually do cat. Let me cut this. Please, if you want to, I don't know. Did I expose I don't know if I'm pressing my private key, but this is, I don't know. Yeah. So this is it. Have you seen? We have truth, RG2. So basically, yeah. So yeah, that's fine. You can actually see it. So basically what we're doing is we created an account and it's deployed. It's false, legacy false. This is my private key. And has it been deployed? False. So we're going to deploy this account. Remember, if you create an account, you must deploy it on Starknet, right? So this is the private key. Please, for production, don't do this, right? And you can see that all of these accounts are in where Alpha Sepolia. So yeah, so what I want to do here is for testing anyways. So what I would do, I want to fund this account. So what I'm going to do, just copy this address and go to the faucet, right? So I'll go to Starknet faucet, Starknet, Starknet faucet. So yeah, this is the Starknet faucet. I'll paste this address there. No, I think, yeah, so this is it. Just paste this account there. So I want stack tokens, verify, automatically it will send some stack tokens, because before I want to deploy an account, this is the step, right? So this is the next thing I'm going to do here is to copy this command. So let's just even type it out, right? So I'm going to tell you what SN cast, SN cast what? SN cast account and deploy -u, or my -u will be my HTTP /localhost, right? And port what? 5050. That is all, right? And the name of the account is what? The account name is what? What's the account name? The account name can be denoted as what? N. And I want to deploy what? Truth. Truth is the account that I recently created right now. So yeah, so that is it. So if I run this command, automatically my truth account, I have funded it in the faucet. Though that means I can actually perform transaction on the network. That means, remember when I created this account, there was a one in here. What they say, I should account created successfully, pre-fund generated account with at least some tokens, so that I can actually use it to send transactions, right? So now I want to deploy this account. So if I run this, automatically you will see that, yes. Do you want to make this account your default? Will I say yes? Nope. Okay. So yeah, I don't want to. So yeah, it have successfully what? Deployed this account. So yeah, what has happened? We can actually visit this URL to see that this account has been deployed. What did we do? We're not using any third-party provider. We're using our own local what? RPC. So yeah, so I paste this here. Automatically, you can see that. You can see that this account has been created. Yeah, it was deployed, right? Some few minutes ago, some seconds ago. Yeah. So this is what happened. This is it, 1946, and this is the right time for yeah, basically that. So yeah, so that's that. And when I run cat again, you can see that truth. Have you seen? Truth account is what? True. I've deployed it. So basically, this is how you can actually use this. What do we want to do again? Do you have any Sepolia account you want us to try out? You can actually write to it, you can actually retrieve it. Let's say we can actually, if you have any Sepolia account, you can actually do this on your own. You can actually read a contract. Is there any public contract that you have that's on testnet on Sepolia?
Yeah, I have one contract like that.
No problem. You can actually put it on the chat. So let's say let's
Let me
check
send the contract
stack token. Let's check stack tokens, right? Stack scan. I think there's a tokens page here. Where can I see tokens? I think TPS, stack tokens, view all, I think.
I've sent the address in chat.
Is it a counter contract?
No, not counter. It's one contract I built recently.
Okay, yeah, let's use this. Yes, this, yeah. It's fun. Is it fun?
Yeah, you can do some things like register player. It's for a
No,
game.
no, you're not getting. I mean, is the whole, are you following? Is it fun? I'm just asking your feedback.
Yeah. It's fun.
Oh yeah, so we can actually get player ID. So let's get player ID. If you have any address that you want. Oh yeah, thank you so much, Josh. Get result, okay, this is a game you built. Wow, this is, okay, you know what we're going to do? Get total game count, right? You can actually query it. So it's 21, right? So what I'm going to do, I'm going to interact with that contract from my CLI using instead of passing in my RPC URL, I'm going to be using my local host, which is running, right? So what I'm going to do now is to, let's say, invoke a contract, right? Or let's call this contract, yeah. So yeah, so it's very easy. So we're going to do SNcast, blah, 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 blah. So yeah, so let's do this. Let's say what SNcast, call, I think -u. So anytime I see -u, I'll say you want HTTPS localhost /6060. Then the next thing is what the contract address, 6060 -- contract address. Contract address. What's the contract address? I think I copied it. Let's go there. I think let me copy the contract address. Yeah, let's do this. So yeah, so function, what function are we calling? What function are we calling? What function was that?
Total games count. I think you are calling total
games, right? Total games count, right?
Can we check the Explorer?
Total game count.
Total games count.
Okay.
Total games count.
Get total.
Okay, yeah. Get total games count. Let me copy this so that I don't miss it. Okay. Copy, then come here and paste it. Automatically, You can see I'm not using any RPC. Automatically, you know that, before now, for you to do this, you must, what's it called? Pass in, are we passing an argument? No argument, right? Are we passing an argument here? No, we're not passing an argument, so no argument. So we just call it. So it's going to give us what? 21. So basically, I think it's of type U32. So basically that. So yeah, so do it. Can we write the contract? Yes, we can. Using our,
Let's do like register player. We can do that.
Okay, let me register my player, right?
Yes.
So let's, instead of this, I'm going to do, so it's not the call, it's going to be what? It's going to be what? What's it going to be? It's an invoke, right? Contract address function, register player. So basically, what I would do here is to register player, and it has an argument, right? The argument in this case, let's to perform invoking contracts. So yeah, the argument in this case, what's the argument?
Meant to be the player address.
So yeah, argument is what?
I think is
Want to ask the question?
I'm coming.
What's the logic of the contract? So it doesn't throw error.
I think
Commit guess, join game.
Oh, okay. The player name. The player name is what we have to pass. The name of the player I want to register.
Okay, is it okay? Let's check.
Yeah.
Player name. Okay. It's a failed, right?
Yes.
So yeah, this is stack util function. Stack util converter. So I want to save. Let's say Dave. What's the failed value of Dave? Yeah. So I copy this and paste this here. Let's see. Nice. Register player, and then the name player is what? Dave. That's it. So that means this transaction was successful. So how do I get the the player? Read, get player name, a personal address. What's my address again? Let's say this is my address. I guess it's taking the color, right? Truth.
Yes. So the color will be it will take the color automatically. So the only thing we need to pass is the player name.
So player name. So how do I do that? How do I get player name?
Okay, to get player name, there is a function to get player name there. Get player name. Yeah, it should be.
But again, the most important thing is that the transaction was successful. If I copy this and I go to this Explorer again.
Oh, okay. Is the second question? Is the second function get player name? We pass in address.
Okay, yeah, sorry. I think I got it wrong here. So let me pass in that in my, it was successful, like, right? I pass in player name, and the name is Dave, and yeah. So I think this is the most important thing here. I don't know if there's any questions so far. So this is just how we can actually use our, what's it called? Our Starknet Juno node to perform calls to the network without relying on any. Okay, get player name, right? So get player name. What's supposed to enter? What am I supposed to enter here? Truth. You wrote the contract.
Please come again.
What am I supposed to pass in here to get my name, Dave?
The player address, the address of the player.
What's my address? The caller?
So we called with which account? Is it with the truth? So we can copy the public address for that one.
Okay, if I copy this guy, or if you
Yes.
did MSG, okay, let's check.
We can even do
No,
that once we put in the name.
It's saying the hex test 0. I don't think the logic is correct anyways, but we understand what we're doing at the end of the day. This is not a Solidity or Cairo class. The end goal is to show that we can actually use our Juno nodes to send transactions to the network without relying on a third-party provider, RPC provider like Infra or Alchemy, right? In this case, we're using our default locally deployed Starknet Juno node, and that's how it works, right? So please, nobody should expose their private key. All of these things are test accounts, and then you should not do this anytime, right? So yeah, so basically how we send transactions to the network, how you can leverage your local nodes to propagate transactions. Really, we are coming from development background, and if you want to do this, you must specify that RPC URL of Infura, Alchemy, Blast API, all of the third-party providers, right? But I'm specifying localhost at all times. What that means is the power is in your hands, right? Nobody's going to censor your transactions. I can actually send anybody any money from my terminal. I can actually build amazing solutions of this. I'm part of decentralizing at this point, Starknet is not decentralized. The sequencer at this point is managed by Starkware, just to clarify. So yeah, basically that. But at the end of the day, in the future, there's a roadmap to make Starknet fully decentralized. That means we can actually participate in sequencing, right? Aggregating transactions to form a block. So what is happening basically is the sequencer aggregates blocks, and if you're running a validator client, right, on Starknet, you attest to, you vote, you attest to those those blocks that were created. So basically, that's how it works. Yeah. So guys, that's that. I think if we have more time, next week we'll join again. We'll create a validator client. We can actually see how we can actually be a validator on Starknet, and you will see how that works. All of those staking that you're doing with third parties like Agent and all of that would stake. You can actually dedicate your Stark tokens to an account that I will kind of like deploy as a validator. So that is how it's going to work. And it's going to be fun. We're going to have amazing time. Same time next week. Let's do this, guys. I don't know if there are questions. Let's take those questions before we call it a wrap. Thank you so much, Naomi. Are there questions? Ebun, Truth. It's an amazing time with you guys. Thank you. I had fun teaching. I had fun explaining myself. If you have any questions, please feel free to reach out anytime, right? My Twitter handle is DV_NMD. You can actually ask me any question. And Ebun, I'm happy to hear from you anytime. Thank you for joining us. We look forward to having more of you guys having these sessions all the time. Yes, the video will be posted on YouTube. Yes, the video will be available on YouTube. And I'll also post it on Twitter. After this call, as soon as it's exported by Zoom, I'll post the videos, right? So yeah, I can actually revisit and watch over and over again. And yeah, thank you so much, guys. I had fun. Have a wonderful evening.
All right, thank you very much. Bye.
Thank you so much. No problem. Bye.